session that is related to D3x60, and the topic is gradient of parallel and perpendicular lines. So in today's lesson I'm just going to have a discussion on gradient of parallel and perpendicular lines. So first of all, starting from question number 1, find the gradient of a line which is parallel to. Part A says y is equal to 8x plus 5. So basically the concept says that if two lines are parallel like this, then their gradient are also same. Whatever the gradient is of this line, that is represented by m, gradient is represented by m, whatever is the value for gradient of this line. Suppose if this gradient is a, then because these two lines are parallel lines, then gradient of this line must be a. Hence gradient of parallel lines are same, gradient of parallel lines are same. This is the basic concept. Now question number 1 is, as I have just said, find the gradient of a line. We have to find gradient of a line which is parallel to this line. So in part A we have been given equation of a line y is equal to 8x plus 5, and we have to find gradient of a line which is parallel to this line. The first of all, find gradient of this line y is equal to 8x plus 5. Now you are going to compare it with the general form of equation of a straight line y is equal to mx plus c. So when you will compare these two, where this is general form of equation of a straight line, then whatever is with x in this form, whatever is the value with x, that represents m is gradient. So gradient of this line is 8, this line. So a line parallel to this line must have the same gradient. So a line parallel to y is equal to 8x plus 5, now that has the same gradient, and that is m is equal to 8. So answer is 8 for this part. Now in question number 1 part B, we have been given equation of a line that is minus 1 by 2x minus 7, and we have to find gradient of a line parallel to this line. So the gradient of this given line, if you are going to compare it with general form of equation of a straight line, that is y is equal to mx plus c, where c is y-intercept, m is gradient. So by comparison, gradient is minus 1 by 2 for this line. So m is, that is gradient, is minus 1 by 2 for this line. So the line which is parallel, so parallel line has also got the same gradient, that is m minus 1 by 2, because parallel line has the same gradient. So this concept will be applied here. So question number 2 is, so the answer is basically m is equal to minus 1 by 2 for question number 1 part B. So question number 2 is regarding perpendicular lines, and question number 2 says, let me just point out the question over here. The question number 2 is, find the gradient of a line that is perpendicular to. In part A, an equation is given for a straight line, and in part B we have a different equation because we have a different line now. Now we have to find gradient of a line perpendicular to this line and then to this line. Now when two lines are perpendicular, and let's suppose its gradient is m1 and its gradient is m2, then the product of gradient of perpendicular lines is equal to -1, mean m1 gradient of this line into m2 gradient of this line, they are equal to -1. The product of gradient of parallel or perpendicular lines, that is equal to -1. So here I have to find the question number 2 part A. I have been given a line y is equal to 3x plus 2. Now this is a line and I have to find the gradient of a line which is perpendicular to this one. First of all, find its gradient. Now comparing it with y is equal to mx plus c in order to find the value of m. So m will be 3. Now this m belongs to this line. What about perpendicular line? As I have told that perpendicular line has a gradient. If you will multiply gradient of this line and the perpendicular line, their product must be equal to -1. So let's take it m1. Let's take it m1 and m2 is the gradient of perpendicular line. Just write it over here. m1, the gradient of given line as we have obtained is 3. m2, which is gradient of perpendicular line, gradient of perpendicular line, okay, that is to be obtained, gradient of perpendicular line, and according to the formula m1 dot m2 mean if you will multiply the gradient of the two lines which are perpendicular, their product must be equal to -1. m1 is 3, the gradient of given line, while m2, the gradient of perpendicular line, is to be obtained, that is equal to -1. From here m2 be equal to -1 by 3. So this is the answer for this part. Then we have question number 2 part B. This is question number 2 that says find gradient of a line. Question number 2, find gradient of a line perpendicular to this line. So first of all, we are going to find gradient of this line, and then by using the equation m1 dot m2 equal to -1, that is equation that represents product of gradient of two perpendicular line is equal to -1. From here we can find gradient of perpendicular line. So question number 2 part B, the line is y is equal to -3 by 4 x plus 6. Okay, now what is the gradient of this given line? By comparing it, y is equal to mx plus c. If you will compare it with this one, then from here the value for m will be -3 over 4. So m is -3 over 4. This is gradient of this given line. Let's take it as m1. m2 is the gradient of perpendicular line which is to be obtained. Right over here, gradient of perpendicular line. Okay, and we have to find its value, gradient of perpendicular line, and by the formula m1, the gradient of m1 into m2, the gradient of line perpendicular to this one, that must be equal to -1. So if these two lines are perpendicular, gradient of this line is m1, gradient of this line is m2. Because they are perpendicular, so the product of the gradient should be equal to -1, where m1 is -3 over 4 and m2 is to be obtained, that is equal to -1. Now from here you will move 4 on the right side and 3 on the right side as well. So m2, the gradient of perpendicular line, will be equal to -1 into 4 over -3, and that will give you m2 4 over 3. So this is the answer for question number 2 part B, gradient of perpendicular line. In question number 3 of exercise 6D D3, Seventh addition. This is question number 3 right over here. The coordinates of 4 points. The coordinates of 4 points are, we have a point O that has coordinates 0, 0. Then we have got a point A with coordinates 2 and 3k. Then we have got a point B having coordinates 4k and 6, and a point C having coordinates 10k and 7. Now find the value of k if the points O, A, B are collinear. Okay. So keeping this question in front of us, let's solve this over here. We have been given 4 points and question number 3, part A. Now the given condition is points O, A, B are collinear. Collinear means they lie on the same line. Okay. So that says that, let's suppose we have a straight line and we have a point O, then we have got a point A, and then we have got another point B. Because they are collinear, so they lie on the same line. Coordinates of O are 0, 0. Then coordinates of A are 2, 3k, and then coordinates of B are 4k and 6. Okay. This is the condition. We have to find the value of k. Now because all of these 3 points lie on the same line, and this line has the same gradient either over here or over here. So if this is m1, the gradient from O to A, and if suppose this is m2, the gradient from A to B. So because the on a single line, on a straight line, the gradient should be same over here as well as over here. So m1, that will be equal to, using the formula y2 minus y1 over x2 minus x1, the formula for finding the gradient or obtaining the gradient, that is 3k minus 0. This is y2, this is y1, 3k minus 0 divided by x2 minus x1. Okay. Now this is m1. Now find m2. That will be y2 minus y1. m2 is from A to B. So y2 minus y1, that is 6 minus 3k divided by x2 minus x1, that is 4k minus 2. Well, that is the value of m2, and this is the value for m1. As I have told you that we are on the same line, so gradient of the line over here and over here, that will be same. So you can equate m1 and m2. So equating m1 and m2, we can have 3k over 2, the value for m1, that is equal to 6 minus 3k over 4k minus 2, the value for m2. So cross multiply them. 3k into 4k minus 2 will be equal to 2 into 6 minus 3k. Okay. Now from here, 3k into 4k will give us 12. 3 4 times 12k into k is k square minus 3 into 2 6k, that is equal to 2 into 6 12 minus 2 into 3 6k. Now from here 12, we need to find the value of k. Move minus 6k on the right side, so 12k square will be equal to 12 minus 6k plus 6k. When you will move this minus 6k on the right side, it will become plus 6k, they will be cancelled. So 12k square is equal to 12, so k square will be equal to 12 over 12, and from here, upon taking square root on both sides, you will get plus minus 1, the value for k. This is question number 3, part A. and we have to find the value of k for part number A when these O, A and B, they are collinear. So you have obtained the value of k, that is plus minus 1. Now what about part B? OA is parallel to BC. Now OA is parallel to BC. So question number 3, part B, given condition is OA is parallel to, let me see again, OA is parallel to BC. Question number 3, right here, question number 3. So OA is parallel to BC. Now if they are parallel, then M, that is gradient of OA, that must be equal to M, that is gradient of BC, right? So we need to find gradient of OA and gradient of BC, and we need to equate them because they both are parallel, and parallel lines have got the same gradient. So what's the value of O? As you can see, OA and then OB, just see, sorry. Now for we have to write the coordinates of O and A. O is 0 0. Okay, the value for O is 0 0 and A is 2 3k, 2 comma 3k. Similarly, the coordinates for B are given, that is 4k and 6, 4k and 6 over here. So B is 4k and 6, and C is 10k and 7. C is 10k and 7. So finding the gradient for OA, so y2 minus y1, 3k minus 0 divided by x2 minus x1, that is 2 minus 0. So gradient of OA will be 3k by 2. Now this is the gradient for OA. Now we need to find the gradient of BC, and then we will equate them to find the value of k. Now gradient of BC, MBC, where B is 4k and 6 and C is 10k and 7. Now y2, using the formula for gradient, y2 minus y1, 1, x2 minus x1, 10k minus 4k will give you 6k. Now this is gradient for BC. Now because OA and BC, they are parallel, so gradient of OA must be equal to gradient of BC because parallel lines have got the same gradient. So gradient of OA as obtained previously is 3k minus 2, and that must be equal to 1 over 6k, the gradient of BC. Cross multiply them, it will be multiplied over here, it will be multiplied over here. So 3k into 6k will give us 18, k into k will give us k square, and 2 into 1 is 2. From here k square will be equal to 2 over 18, and you can simplify this one, and when you will simplify, 2 and 18 will be cancelled, so 1 over 9 and taking square root will give you plus minus 1 over 3 as the value for k. This is answer for question number 3 over here. Now question number 4 is coordinates of 3 points A, B and C. They are, and now find the value of k if AB is perpendicular to BC. Again, starting from question number 4 now of D3, exercise 60. Well, this exercise is being done upon the request of one of my students. So just give me a minute, please. Okay, right over here. We have been told that you have to find the value of k, and AB Now that is perpendicular to BC. Now that means slope of AB into slope of BC. Now their product must be equal to -1, as the case is for perpendicular lines. Now we can find the slope of AB. We have been given the coordinates of AB. So y2 minus y1, I mean 4 minus 1 divided by x2 minus x1, that is 3 over minus 2. That is slope for AB. Now find slope for BC. That is y2 minus y1 k minus 4 over x2 minus x1. That will be k minus 4 over 7. That is slope for BC. Now we have obtained slope for AB, and we have obtained for the slope for BC, because it is given in question that AB is perpendicular to BC. Both are perpendicular, so their product of the slope should be equal to -1, which means MAB, which is 3 over 2, using the condition over here, MAB is 3 over -2 into MBC, means slope of BC, which is k minus 4 over 7. Now that is equal to -1. Now from here we can simply multiply 3 into k minus 4 over -2 into 7 is -14. That is equal to -1. Now you can move this -14 on the right side of the equation, and when you will move it on the right side, it will be multiplied with -1. -14 into -1 will become +14. Now from here 3k is 3k, 3 into 4 is 12, equal to 14. Move -12 on the right side, it will be added in +14, so 3k will be 14 plus 12, 26, and from here you can find the value of k, that is 26/3. So this is the answer for question number 4 of exercise 6D D3. Question number 5 is, moving towards question number 5, intermediate level. Now we have to find equation of a line which is passing through a point in path A, and it is parallel to the line 3y plus 7x is equal to 29. Now when we have been given a point and we have a parallel line, I am going to use over here point slope form. Question number 5, part number A. We have been given that find the equation of a line. Okay, so first of all, y minus y1 is equal to mx minus x1. Now this is point slope form. If you want to find equation of a line, you can use this point slope form. What it says that we have to use coordinates of a point through which the line is passing. So I am going to use y1 equal to 5 and x1 equal to -2, and we need to have a slope of the required line, and that line is parallel to this line. So from here we can find slope of the required line, because this line and this line, they are parallel, and when two lines are parallel, their slope are same. So using this equation to find the slope, so first of all write this equation. I need slope of the parallel line. So this line is parallel to the required line. Okay, so we can find slope if we will express it in this form, y is equal to mx plus c, which is general form of equation of a straight line. So you can do that. You have to make y the subject over here. So move 7x on the right side. So 3y will be equal to 29 minus 7x. Isn't it? Yes. 29 minus 7x. Okay. Now from here, y will be equal to 29 by 3 minus 7 by 3x. Now you can compare it with this equation, y is equal to mx plus c, where the value with x represents m. So this m is the slope of the given line, this one, and this line is parallel to the required line whose equation is to be obtained. From here we will obtain the equation of a required line, and keep in mind that this required line is parallel to this line, so slope of this line is this, and because the two lines are parallel, so we can use this slope over here because these two lines are parallel. So putting the value of slope over here, y minus y1 is equal to, in place of m, use minus 7 over 3x minus x1. Now what to do next? We need y1 and x1, and you can use the coordinates of this point y1 and x1 because the required line, the line whose equation is to be obtained, is passing through this point, and when the line is passing through this point, you can use the coordinates of this point in the equation of the line. So y1 is 5 and x1 is minus 2. So y1 is 5 and x1 is minus 2. Solving further, it will be y minus 5 is equal to minus 7 over 3 x plus 2. Move 3 on the left side, it will be multiplied with y as well as with 5. 3 into y is 3y, 3 into 5 is 15, equal to minus 7 into x is minus 7x, minus 7 into is minus 14. And you can rearrange it. 3y minus 7x, when you will move it on the left side, it will become plus 7x, that is equal to minus 14 plus 15, and minus 14 plus 15 is what? Plus 1. So this is the equation of the required line, that is from question number 5, part A. So I am just concluding my lesson up till here, and I will upload the rest of the part in the next section of this lesson. Keep watching. Thank you so much, and subscribe the channel. Thank you so much.